Chúng tôi xin cảm ơn quý anh chị đã dành chút thời gian đến tham dự buổi hội thảo hôm nay. Mình là Thanh, Sales Manager phụ trách mảng bơm Armstrong và đồng thời là bơm Armstrong. Hôm nay Thanh sẽ làm MC dẫn dắt chương trình này. Lần trước Thanh xin gửi đến quý anh chị lời chào trân trọng nhất ạ. Ngoài ra sẽ có anh Phan Ngọc Quân là Sales Manager phụ trách mảng chiller, và anh Đặng Công Lý là Assistant Sales Manager phụ trách mảng PMS Solution Control. Về phía Armstrong thì có ông Wesley Phong, Regional Marketing Manager, Mr. Chris Han, Regional Sales Manager, và ông Ronnie, Product Report Team Leader. Sau đây xin mời ông Michael Chiu đến mời lên khai mạc phát biểu.
Chào buổi sáng ha, good morning. Công ty cổ phần Appliance Việt Nam xin gửi lời chào trân trọng và cảm ơn quý vị đã dành thời gian quý báu đến tham dự buổi hội thảo giới thiệu thương hiệu máy bơm Armstrong, challenging the traditional approach to HVAC pump solution. Với mục tiêu trở thành sự lựa chọn hàng đầu của khách hàng khi nói đến giải pháp tích hợp tòa nhà, Appliance Việt Nam không ngừng lựa chọn các dùng sản phẩm ưu tú để bổ sung vào bộ sản phẩm của mình. Armstrong Fluid Technology được cả thế giới biết đến là đơn vị tiên phong đổi mới trong thiết kế, kỹ thuật và sản xuất các thiết bị công nghiệp thông minh. Armstrong là đơn vị duy nhất kết hợp phần cứng và phần mềm chất lượng cao để điều khiển thông minh cũng như các dịch vụ liên quan đến giải pháp tích hợp năng lượng. Đến với thị trường Việt Nam, mục tiêu chính của Armstrong là giúp khách hàng tối ưu hóa thiết kế hệ thống bơm HVAC để đạt được hiệu suất hoạt động cao nhất có thể cũng như chi phí hoạt động thấp nhất bằng cách tiếp cận một khái niệm mới cho việc lựa chọn và điều khiển bơm thay thế cho dùng các truyền thống. Bằng việc trở thành nhà phân phối độc quyền sản phẩm bơm HVAC tại thị trường Việt Nam, Appliance tin tưởng rằng Armstrong sẽ sớm trở thành một trong những sản phẩm nổi bật cùng với các sản phẩm khác trong giải pháp thiết kế tối ưu hệ thống bơm HVAC cho các công trình xây dựng, thương mại và công nghiệp mà Appliance Việt Nam đang hợp tác cùng với quý vị. Xin trân trọng cảm ơn Armstrong đã hỗ trợ chúng tôi tổ chức buổi hội thảo này. Xin cảm ơn và hy vọng quý vị tận hưởng sự kiến hôm nay. Cảm ơn. Quý vị không có tốt xin nói nhé.
Thank you for attending today's seminar. My name is Wesley Phong. I'm the Regional Marketing Manager for Asia and China, representing Armstrong. We'd like to present to you an overview about Armstrong, whereas we believe in success through synergy. Armstrong Fluid Technology, which is headquartered in Toronto, Canada, was started in 1934. So we are actually one of the leading companies in terms of innovative solutions for fluid control as well as for the pumping in HVAC and or water-based process solutions. So it started by our founder Samuel Allen Armstrong in 1934 before it was passed to his son, which is James Armstrong, and now it's succeeded by the grandson, James and Charles Armstrong. So you can see over 80 years or more, right, we have actually been in the business of designing the pump innovations. We started off with design envelope technology, the innovative vertical inline pumps as well as design envelope solutions. And we continue on with various control technologies solutions through the market as well. So we are actually a global company, although we started in Canada. As you can see, 50% of our workforce is actually outside of North America. So we have actually about 7 facilities in 3 continents, With North America, the factories in Toronto and Buffalo, America. And then in the Europe, we have in Manchester and Birmingham. And for Asia, we have 3 sites in Bangalore, which actually where our Asian-based foundry and also production is, as well as in China that supports majority of our Asia-Pacific markets. So what you can see is that with over 1,000 employees across 5 different continents and over 8 new manufacturing facilities as well, over 84 years we have actually been sustaining and supporting the business for the fluid technology in the HVAC and water pumping business. So our first presence in China basically started in Shanghai, and this is where our factory and also our sales office is located. And we started off to actually develop the sales office in the other regions in the north, which is the capital Beijing, in the west, which is Chengdu, as well as in the south, which is in Guangzhou. So in other countries in Asia Pacific, we actually are supported by our regional and local distributors. So here in Asia, here in Vietnam, in the Asian market, I supported by appliance for both the entire north and southern region. So a little bit about our Armstrong factory in China, Shanghai. It's actually a wholly owned company. So basically, Armstrong owns this facility fully 100%, whereby we actually have the full control over production, testing, and manufacturing all our products and solutions, testing and services. So we also actually provide after-sales service support as well. So supporting not just the China market, but also the entire Asia-Pacific market. And we have been running this since over 20 years now in China. So a little bit about what we can actually deliver from our Shanghai factory is that you can see over here a 700 kilowatt vertical pump, right? The size of a human being. So we can actually develop from a very small pump to a very big project, mega project, as well as can do various assembly lines, testing of our pumps before we ship out, as well as a delivery and warehouse as well for all our reps in the Asia region. And a little bit about our Armstrong hierarchy here in Asia Pacific. So it's led by our Boy Tan, who is actually the commercial director for Asia and China, and parallel functions with the HR and finance. So for the team here comprises of the Asia sales. So later on you will have Chris Han, who is actually the core business for Southeast Asia RSM, who will present to you our Armstrong solutions, as well as the technical support, which is provided by Ronnie Ke. He's the overall core business for Asia. And also the service team that runs multiple tasks in terms of the warranty and transactions of the parts and labor, as well as upgrade services, and also installation and evaluation of performance management, and also power manager services. So we'll talk about that later on as well. So we have multiple functionality, as well as marketing, which is led by me. So when we talk about Armstrong brand, it's actually 3 core principles that we have here. So one of them is the learning and innovation. So we actually learn from our customers essentially what is the voice of the customer, the market needs, and thus we actually continuously innovate and develop solutions for the market. And coupled off with our strong integration with the community, both local and global, we're able to enhance and build that strong relationship with the customer. Primarily now that Armstrong is a strong supporter of the World Green Building Council. And of course, we provide solutions in terms of after-service support that enhances our entire product lifecycle portfolio. So through this, it's essential for us to actually create the customer value. So a little overview about our product solutions in terms of the pump portfolio. So when we look at our various product ranges, it actually increases in terms of functionality and capability, from a very basic standardized horizontal pumps and suction pumps to a more vertical inline that encompass with the accessories such as multifunctional valves and also suction guides, and also integration into a booster sets, as well as a full system solution. So when we talk about integrated solutions, it's not just on the mechanical side, which is the pump, but we also talk about the control side. So you can see very well we started to integrate on with the controls, which is a standalone VFD that we actually be able to enhance to what we call a design envelope. So from the design envelope, we're able to incorporate further with the intelligent twin pumps and also a full system. So with a product that comes with a solution, naturally we enhance this with the system solution as well. So when we talk about system, it's really a full solution from the very fundamentals of your mechanical to your electrical and also your overall plant control. So we can actually provide you with a more integrated distribution system base, as well as a more chiller control or a full plant room system solution. So really, when we talk about this Armstrong portfolio, it's actually a journey by providing you with a solution from a product standpoint all the way to a full organizational capability. That means an entire plant room system control. So with this, you can see very well how it actually helps you to increase your system efficiency and overall capability. So when we talk about how we actually have this sort of core competencies, right? Of course, fluid control is one of them, but also with our expertise in the HVAC, which is the heat transfer, and we will couple with the control system in terms of variable speed and demand-based control that lead us to provide you with the integrated solutions. So the integrated solutions come from a single, a bit more modular to a more variant, heavily integrated solutions. So essentially what this means is it provides you with an optimum building performance management and control. Okay, so when we really talk about optimal performance management control, we're really talking about optimization. Now, a lot of people will understand, when we talk about plant optimization and also automation-wise, right? It's really about how you be able to first assess your operations on a real-time basis, as well as be able to enhance the performance, of your plant. So you want to make sure that not only you're sustaining the performance, but you actually be able to improve as well over time. So this is what we call the performance management. And of course, we have multiple applications, not just in the HVAC system. We also have installed in many various commercial buildings, malls, hotels, infrastructures like airports, educational systems, campuses, and so forth. And these are some of our install base around the world. So you can actually read more about our expertise in the various applications on our website, which is the armstrongfluidtechnology.com, and it'll cover all of these solutions for you. So just some pictures to show you, the different packages that we offer in terms of the HVAC that you can see here, as well as a big stellar power project that we developed for the Middle East. Okay, thank you very much for a quick overview of Armstrong.
Thank you, Mr. President. So next we invite Mr. Chris Han to present about the Armstrong solution.
Hi, my name is Chris and I'm in charge of Southeast Asia. So today's topic is on challenging the traditional approach to HVAC system. So during this section of mine, I hope that you can take down some notes because perhaps there are some new concepts that you will be exposed to, and I hope to maybe in my next visits or so see you personally, visit you at your office so that we can explore some of these concepts that are going to be shared over the next few slides. Okay?
Thực ra cái Armstrong của mình là một cái concept thiết kế tương đối là mới, do đó suốt cái present này thì có thể là có những thông tin quý vị chưa có rõ, thì sau đó nếu quý vị những cái gì chưa rõ có thể là hỏi tại đây hoặc là gửi lại câu hỏi, sau đó là Chris sẽ có thể giải đáp sau cho quý vị về những cái concept design tương đối mới này.
And of course, feel free to ask questions, whether it's during my presentation or during the break times. So for HVAC industry, fluid flow is something that is a component that connects all the main equipment in the system. Right? If you see the diagram on the right, starting from the basic pumping system that deals with water distribution, or whether it's chilled water pumps or condenser water pumps, right? The flow rate basically drives the decision on what are the operating speed, if you're using a variable speed drive, as well as what are the main equipment choices to make. Yeah. If you see also on the right hand side here, that is what we call our design envelope integrated drive. Okay, where we integrate our inverter together with our pump. Within this integrated drive, we do have a flow meter functionality, and this gives you accuracy of ±5% of the BEP flow rate, best efficiency point flow rate, and this is actually much more accurate compared to the flow meters in the market, which are typically around ±10%. Yeah? And after you have installed all your equipment, we know that a well-balanced system is very, very important. So a well-balanced system is very important because this will actually influence your efficiency, your plant room efficiency, as well as your reduction in operating cost. Okay, the first concept, a new concept perhaps, or maybe not, I want to introduce to you about redundancy, or an alternative name is called backup. So we know that the HVAC industry will generally be designed to have a backup, and if we were to do a definition, it is a percentage of system design flow available when one of the pump fails. Okay, later on I'm going to share more examples on this. And I believe in some of your existing designs, right, as engineers, consulting engineers or designers, you basically have your pumping system designed as a duty standby. Am I right? As you can see here, this picture looks very familiar to you. You use a traditional end suction pump with one of the pump operating at one time and the other on standby, giving you 100% redundancy in case of a failure or a maintenance requirement. The second concept I want to share with you, and again, you would have known, HVAC industry basically it's a part load industry. So that means we are not operating at 100% of the design demanding at all times of the day. Correct? If you were to do a statistics over time, I would say that 90% of the time we are only achieving or requiring 60% of the load, about 90% of the time. Okay, so what does this mean is that when we size our pumps for part load, we can actually select smaller pumps to handle this lower flow requirements. Yeah, follow? So when you have two pumps, two smaller pumps in operation, right, and if one pump fails, we'll still be able to have sufficient redundancy or backup in case there's a failure, and this backup will be able to handle the flow whenever this failure occurs. And over here in the box, you will see that unlike other equipments like boilers or chillers, right? The pump's redundancy is not a 1-to-1 ratio. Okay, it's not determined by the number of pumps. A concept that I want to share with you is about capacity split. Okay, and this becomes useful when there is a multi-pump system. So in this case, I'm going to consider two pumps, all right, with a design flow of 19 liters per second. Now, if we could consider 50% capacity split with two pumps running, that means we are generating or each pump will have 9.5 liters per second. Yeah. If you have 2 times 70% capacity split, That means each pump will have 13.2 liters per second. And what if you size your pump for 2 by 100% capacity split? That means you have a configuration of a duty standby, or you can operate as a parallel operation. The picture you see here, this logo here, you see is actually our selection tool. So this selection tool is actually open to all of our customers. For you, you can also log into our website and try our selection tool. So within the selection tool contains all the technical data they require. So it's pretty straightforward. You enter your flow and your head requirements, and you generate the data sheet. So from there, from your data sheet, you can make an informed analysis and decision on how to best design your system for your clients. Okay. Now, just now I've talked about redundancy. I've also introduced capacity split. So maybe the next question you might have is, what is the effect of capacity split on redundancy or backup? So if you were to follow the gray line here, that is the combined pump operating curve when two pumps are combined or in parallel. Should one of them fail, we are going to operate on the single pump curve, on the red curve. And you realize that even though it's operating on a single pump curve, it is still intersecting the system curve, system resistance curve. And at this intersection, right, if you were to drop down, you might, based on this graph, it's only able to deliver 50% of the load requirement. However, again, our pumps come with our integrated drive. It means with our intelligent controls, it is able to speed up the pump to the maximum motor speed or the capability, such that it's able to achieve 70% flow of the design flow. Right? So that means instead of having 50% redundancy, with this arrangement, you are able to achieve 70% redundancy. Okay? So some other options that you can have when you have 2 by 50%, you're able to have 70% flow redundancy available. If you have 2 by 70% flow capacity split, you can have 85% flow redundancy available. And of course, lastly, if you have 2 by 100%, you can have 100% flow redundancy. Do not worry, I believe these slides will be made available to you at the end of the seminar. So feel free to request it from appliance. Okay. Do feel free to write notes so that you can follow along. I hope you're following along pretty well. All good? Yeah. So what does 80% of the design flow have the effect on the cooling coil as well as the heating coil? Based on this graph, at 80% flow, you're still able to have 95% of the cooling coil emission. And also for 85% flow, you're able to have 98% of the heating coil emission. So what does this mean? That means even though you do not have your 100% redundancy, there is still a comfort level, a minimum comfort level for your occupants, even if you're operating at 80% design flow. Okay? Next, why do you use parallel system? Right? So if you're following along the presentation so far, what I've been driving, the concept I've been driving is about having parallel pumps. Okay? So when you have two smaller pumps operating at 50% capacity split, you have basically around 5 advantages. So number one, you can reduce your capital equipment cost, right? This is because when it comes with smaller pumps, smaller motors, you can save on the initial equipment cost. Next, you can have also a reduction in energy cost. Because with our parallel pumps, we have this patented methodology called best efficiency staging, This I will share with you later. Next, with the smaller pumps, again, you reduce your size. That means your equipment footprint reduces. So that means if you are designing a chiller plant room for a mall with a reduced mechanical plant room, basically that means the owner has more space to rent out to tenants, more money in their pocket, a happy client for you. Okay, and of course with the smaller pumps, you're able to also reduce your carbon footprint. And all of these are still having your redundancy capabilities. Okay, next. This is something that perhaps you may find a bit interesting, because I believe not all manufacturers do this, use this approach. If you can see and if you can follow along, on the y-axis, maybe I'll choose a point 90 feet, okay, 90 feet of head. And the x-axis, I just put it at 900 GPM. So if you do follow along this graph, so basically what you get is at this spot here, okay? So if you see the spot here, if you were to have a requirement of a non-overloading requirement, you are unable to use the 25 horsepower, because your end of curve will exceed the motor horsepower curve. So what do? We have to go for the next size, which is 30 horsepower, right? If you to realize that if the 30 horsepower over here, it is intersecting the 11.44 inches impeller size. Okay, so for us at Armstrong, since we are already going to use the 30 horsepower motor, why don't we push, or rather we optimize the impeller trim? Instead of using a 10.78 inches, why don't we use 11.44 inches? What does this give us? That means we increase our range, right? Operating range available. Okay. So what is so different is that what we do is our operating portion here goes along your head curve, and it will follow the motor horsepower curve straight down to ensure that there is no exceeding of the horsepower curve. Okay. So again, the first sentence, right? Impeller trim is optimized to the motor power. So what does this mean? If you realize that there is these circles here, these circles indicate where the best efficiency points are for each of the impeller sizes. And you realize that there is an intersection between the motor curve as well as the best efficiency point over here. So again, we'll ride along this curve downwards, and where this intersection is, it will drive down all the way to the end of the curve. And this is what we call, we have actually an electronic load limiting capabilities within our pump to ensure that the motor horsepower is not exceeded. Okay. It's a bit of a lot of words, but I hope you understand my explanation. Okay, later on my colleague Ronnie is going to introduce to you our Generation 5 pumps, Tango pumps, which is basically available up to 10 horsepower. Okay. These 10 horsepower motors are equipped with an IE5 capabilities, IE5. I mean, it's IE5 ready. Okay. So I know right now IE4 is pretty common, and IE5, when it comes more prominent into the market, we do have the solution. So what this slide or what this graph is trying to tell you is that with our IE5 motors, IE5 ready motors, there's going to be less drop-off in efficiency at lower speeds. So, and why is it able to do this? Is because we're using a permanent magnet motor. That means the slip loss is less, giving you a higher efficiency, even at lower speeds. Okay, next, another perhaps a mindset shift for you is this. Traditionally, if you approach a lot of the other manufacturers, pump manufacturer, what they do is perhaps they select a pump that is to the left of best efficiency point. Okay? So if you were to follow this graph on the left-hand side, the best efficiency is around 82, but now the operating point is to the left of the EP. Okay? And this is at full load, okay, 100%. And again, since HVAC is a part load industry, we drive it down to 50% of the design flow. These are the readings, right? So the efficiency is 67.1% with a 9.606 brake horsepower. If you have to do the calculation, the math, it is about 67.5% energy savings. And if you're very familiar with the ASHRAE standards, 90.1, it states that at 50% flow, it has to have 70% energy savings. So since this is 67.5%, it does not meet the requirement, right? Because it's below 70%. Now, what does Armstrong do differently? Again, if you see the best efficiency over here is at 85%. What we do is we select a point, or rather our duty point is to the right-hand side of the BEP. Okay, so even though at 100%, our efficiency is 68.1%, but again, we are considering part load. So let's take a look at part load. Our efficiency increases to 83.2%. And based on this calculation, again, we are able to achieve an energy savings of 77.5%. Again, this is above the ASHRAE 90.1 requirements of 70% energy savings at 50% design flow. Okay? Now, because let's consider you are trying to deliver some, the fluid from point A to point B. So, what these diagrams are trying to say is that so long as you're delivering the right flow, the right head, the system doesn't care how you deliver or in what kind of configuration. So you can either choose one pump at duty, 2 pumps on duty, 3 pumps on duty, or 4 pumps on duty. Regardless, it still gives you the required head and flow. Okay? And if you were to do, just to pick one example, let's say for example 2 pumps. So 2 pumps, you can have 3 types of combination, right? One is 1 duty, 1 standby, each size for 100% capacity. Or you can have 2 duty, each size for 50%. Or you can have 2 duty, each size for 75% capacity split. And what factors influence which option should you use is all listed on the right hand side here. So basically you can consider, some of the factors to consider is which of these options gives you the first or the lowest install cost. Which one will give the owner the lowest operating cost? Which one will give the owner a smaller footprint that gives them more space to do more things for their building? Which of these options give you a better redundancy backup plan, or in terms of electrical infrastructure as well? Okay. And again, this is just some background on how the single pump. So the graph on the left hand side, basically it's a system where 1 pump is in operation, or 1 pump is designed with 1 pump. Okay. And when you have 2 pumps, when you design your system with 2 pumps in parallel, so basically this is how it looks like. Okay. So at every point, capacity doubles up. Okay. And also take note that each pump is actually of the same size, and whenever you reduce it to single pumps, you still have to intersect the system curve. So again, I would like to give just in terms of numbers, because numbers don't lie and numbers tell a lot of story. So here we can have, I'm comparing 2 scenarios. One is a duty standby against 2 by 50%. So the first row here is 1 duty, 1 standby. The second row is 2 by 50%. Okay. So again, if you were to do the sizing, this is the flow rate per pump. The motor size will reduce for the 2 by 50%. Okay. And the redundancy, of course, we have shown earlier on. This is just some of the averages that we have received. Okay, so in terms of a 3-year installed cost, I mean, this is over a period of time. Okay, the total installed cost is greatly reduced by 43%. Okay, and operating costs over a 3-year period is close to 8% savings. Okay, so all these numbers, of course, are good for you to reflect upon, and of course we have a lot of field experience to tell you that these are some of the numbers we have achieved for our customers. Next, this graph basically wants to share with you that what is the part load efficiency comparison between a duty standby, which is the curve in blue, versus parallel pumps, whether is it 1 pump running or 2 pump running. If you were to realize that yes, this small little portion, a duty standby, gives you a better efficiency, but in terms of the overall, right, you will see that the red curve, which is the parallel pumps, are much higher efficiency compared to duty standby at part load. Next, when it comes to turn down, so turn down is basically good for applications like your boilers and your variable flow applications. So here for one pump turn down to lower flow rates. So basically it's a 4:1 turn down ratio, okay, to 30% of your BEP. It's at 24%. And when you have 2 pumps turned down, basically what you're able to achieve is 8:1 ratio, and at 12% of your design flow. So this is again what is turned down. So turned down is the percentage of design flow at which the flow becomes stable and is able to be accurately measured. Okay, now we'll talk about carbon footprint or space savings and all. So basically now we're talking about, again, duty standby versus a parallel pump. And what we've done is just to compare, right? We know that most of the time we are using an end suction or a horizontal split case. So when you use a vertical inline, you will know there is actually much savings. Right now what we're trying to illustrate is that now we're going to use vertical inline and we're going to compare it against our tango pumps. Okay? So you realize that our horsepower has reduced, right? And the sizing also has reduced greatly. So you see the diagram on the left, okay, against our tango pumps. The table here basically shares with you some of the comparison. In terms of weight, we have saved about 73% installation weight. Footprint, we have reduced by 81%. Of course, installed cost, we have brought it down, saved about 65%. Okay? And besides that, we also have this pump called the twin pump. So twin pump is actually just slightly more flow and more head in terms of operating range. But again, when we compare a twin pump, our own twin pump, versus a tango pump, there's also cost savings as well as installation weight savings as well. So what we're trying to do is, even within our own product portfolio, we're trying to outdo our own products to ensure that we are always staying forefront of technology, forefront of cost savings, as well as lowering operating costs. Okay. Within our tango pumps, okay, this is called tango. Why is it called tango? If you will see, this is actually 2 motors with integrated drive, or VSD, and you will see that there's only 1 casing. What is interesting is that there's 2 impellers in 1 casing. Okay, and basically it's good because, again, there's all the benefits that you have learned earlier. For example, redundancy is there, and also when it comes to maintenance, you can just use a blanking plate to blank off one side, maintain it, while the other still continues to run. So there is no complete shutdown. Okay. So what is the beauty of this tango pumps is that it comes with our product, our innovative product that we have patented, which is called the PSPC, or Parallel Sensorless Pump Control. It is basically a control logic that controls up to 2 to 4 pumps, okay, for best efficiency operation. This logic that is embedded into the controls requires no external PLC or controller, and also no external DP sensors are required. Alright? We know that DP sensors can be very tricky because to install it, there's always different rules. Maybe some of us put it at 2/3 of the way, some put it as the most remote load, or some just simply put it at a mechanical room. And of course, there's always about the issue about maintaining, right? Maintaining of the DP sensors. Some of our visits to site, some of the DP sensors at site are not working, right? The owners do acknowledge it's not working, but again, it's too troublesome to do a retrofit and to replace the DP sensor. And again, also, of course, you need to consider the wiring, right? The wiring back from the DP sensors at wherever location you have located, back all the way to your VSD. So again, there's a lot of cost involved there. So with our Tango pumps or even our design envelope pumps, we do not need a DP sensor. Okay? The beauty thing is that over here, then the question you might ask, or you might want to ask me is that without a DP sensor, how do you know where the pump is operating at? It is because all the data has been preloaded, pre-programmed, and pre-tested at factory. What are the data we collect at factory is 4 points, right? At each speed. 4 points are power and speed, flow and head. Okay, if you see here, power and speed, flow and head. So these are the 4 parameters that we collect during our test at factory, and we embed it and we put it into the controls. So it is able to detect what is the actual requirement of the system, and it's able to control it sensorless. Okay. So these PSPC or parallel sensorless pump control, it is included as a standard in our Tango pumps or dual arm. Okay. But if you want to put it to our design envelope vertical inline pumps, it is come as an adder. That means an additional cost. Okay, here, this is another methodology that we use. Okay, so on top is what I have mentioned earlier: best efficiency staging. The graph on the below is the traditional BAS speed control. Okay, these two graphs. As I go along the slide, I want you to notice what happens on the bar graph here, bar chart here, as I move, as the valves open. Okay. So at the start, yes, there is movement. Okay. Okay. At this juncture here, you will realize that we start to open up, or we start to turn on the second pump. Okay. But while the traditional speed-based BAS control is still operating on the single pump, right? It is going to perhaps run until 90 to 95% of the maximum speed. So even though we are already turning on 2 pumps compared to the speed-based scenario, we are only consuming 18% of the power. However, here the speed-based control, you're already consuming 30% of the power, 30% of the power. So again, this means that in terms of operating cost, our best efficiency staging pumps or methodology helps your owners or your clients save money. Okay, and here you will notice there is this warning sign. So I'm going to put this warning sign at this point. Okay, so the warning sign is going to the graph. Okay, so right now, so these are the points at this intersection of the first and second pumps efficiency graph. This is where it's going to turn on. Okay. Right now, as you can see again, while we are already at our 3rd pump turning on, the speed-based pump is still only at the 2nd pump. Of course, at the end, when it reaches all the way to the end, our power consumption is the same, right? So the greatest advantage we have is what happens in between, right? Is how is our methodology when it comes to turning on the next pump compared to the traditional speed-based approach. Later I'm going to show you what do those warning signs mean. Okay, this is another graph to further enhance your learning. Okay, so again we have our green control curve, right, and as well as now we have 4 pumps, okay, 4 pumps in operation. And again, those points by the diamond, where the diamond points are, those are the intersection between the first and second pump, second and third pump, okay, etc. So these diamond points are basically where the next pump is going to be turned on. Now we have a black curve, right, a black line. So if you realize these lines are actually the combination of each of the best efficiency points of all the four pumps. Okay, so it's going to write on the best efficiency graphs to ensure that throughout the operation is going to be at the best efficiency level. Okay. Okay, just now based on that graph, again you will realize that for speed base, right, it would go all the way to almost 90 to 95% of the maximum speed before it turns on the next pump. Okay, so it's going to stage on at 95, stage on the next pump at 95% of the speed, and stage off at 55% of the speed. So if I were to do shading over here, right? So this again, this diamond point is where Armstrong's approach of staging on the next pump. This cross here is where traditional speed-based approach will turn on the pump, right? So these black areas here, 1, 2, 3, it represents the loss of efficiency due to the late staging on of the next pump. Okay, loss of efficiency. Again, efficiency in terms of in plant room is very, very important, very critical for the overall building performance. Okay. Next, of course, when it comes to staging off, again, we are also staging off late, right? Rather staging off too early. And this shaded area again will show you the loss of efficiency due to staging off too early. Okay. And if I were to integrate our building load profile, okay, this is how the building load profile looks like at the bottom of the bar graphs. So you will see that between 25 to 35% of the capacity and also between 50 to 60% of the capacity, there is a, this is where it overlaps. So what this graph is trying to say is that majority of the time where it's most used is also where the speed-based approach is also giving you the least efficient. But also at the same time, if you use the Armstrong solution or methodology, it's going to give you or give your clients a better efficiency readings, right? So this we say is that there's 30% energy savings from best efficiency staging. Okay, so just now earlier on I talked about these warning signs. So again, I put the building load profile onto this same graph, and you can see that again, between 30 to 40%, this is where it's most most operated at, even at 50 to 60%. Okay. Okay. So now, when it comes to what is design envelope and how is it different from our competitors, so perhaps now I believe a lot of designs are pump with separate mount, wall-mounted VSD with a DP sensor somewhere in your system. Okay, so just now we talked about 3 scenarios, whether is it the furthest away load, 2/3 of the way, or even in your mechanical room. Okay, so basically the changes in the system is read by, of course, the DP sensor, and this will be converted into a signal, 4 to 20 milliamp or 0 to 10 volt, and this the VSD will read the signal and will modulate or regulate the speed accordingly, whether is it speed up or speed down to ensure and maintain the pressure. Okay. But for us, again, I mentioned in our product, basically what it has is our integrated drive with all our embedded information. Again, the 4 parameters that we embed into our drive will be power and speed, flow and head. Okay, so a change in the system is read by a change in the power drawn of the motor and the motor. Okay, so and what happens is that our pump will actually compare what is the power drawn against the data that is already included into the pump, and that is where you will know and you will read what is the head and flow that it's operating at. Okay, and of course it will have the speed modulating function based on the readings as well. Okay. So our integrated controls, basically it gives, there's a function of two-way bypass valve control. It is able to also have minimum flow control, maximum flow control, as well as two-zone controls capabilities. Okay, and all do not need, or rather our flow meter is all embedded into our drive. Okay, so again, just to recap, so if we were to consider now what your designs are, basically, two end suction pumps with wall-mounted drives with an external DP sensor. And I introduced to you our design envelope pumps, which is vertical in line with integrated drives. Okay, and of course the last one I'll talk about our Tango pumps, which is currently now available until 10 horsepower. Okay, so some of the advantages when you use two vertical inline pumps. One is of course reduced installed power. This is provided you have properly sized the pump. Integrated controls, sensorless technology, high level of redundancy, and low space requirement. And now if we go on to the next solution of Tango, again you have reduced installed power, super efficient ECM motors, sensorless technology, high level of redundancy, and lower space requirement. So as we can see that our products over the years have innovated, progressed, giving a lot of advantages back to the customers. And again, what we're trying to do with all our products is two main things. One is to give lowest installed cost, that means benefiting the contractors, and of course lower operating costs, giving benefit to the owners. Okay, now I believe you have designed a lot of plant rooms for different applications. Let's look at the first one on the left-hand side. We call it the generic duty. That means you're designing perhaps for schools, for apartments, condos, and factories maybe. So we propose maybe you can consider 2 by 50% capacity split, and this thereby giving you 70% flow redundancy. And next, if you're designing perhaps high comfort sensitivity, such as hotels, offices, universities, or campus, you can consider 2 by 70% capacity split, giving you 85% flow redundancy. And lastly, mission critical. That means you must have 100% redundancy available. I mean, we're talking about hospitals or blood banks, etc. Very important, or even data centers. So this will be recommend or propose 2 by 100% capacity split with 100% flow redundancy. Okay. So again, through the years, this chart is trying to tell you, rather show that our products have been able to help, rather help our customers experience energy savings, right? All the way from 15%. Okay, 15% energy savings was experienced when we changed from a constant speed pump to a variable speed pump. So the energy savings was pretty obvious, 15%. Of course, through the years, we have increased our product range and increased our research and development. That's why now with our Tango pumps, you can actually experience up to 90% of energy savings. And we call this our Generation 5 pumps. And of course, the next level of thinking, the arrow here, it is all about cloud-based active performance management. This is something that Ronnie, my colleague, is going to go through. That means you're able to monitor the performance of the pump remotely, via even your handphone. And we also have the capability of commissioning pumps from your handphone. So again, if I were to do a quick summary, okay, this is my last slide. So basically, if you are open, of course, there's always opportunities to look at how your designs can change after this presentation. That means moving away from the duty standby to a parallel pumps, or even considering our Tango pumps with embedded parallel sensorless pump control. And of course, with that, you can also help your customers to reduce a lot of operating cost and install cost. And of course, you can experience energy savings over time, about 29%. And of course, with our active performance management, that means cloud-based monitoring, that can save you about 40% of energy through informed decisions in maintaining optimal efficiency. Okay, so with that, thank you for your time. Come, thank you.
Thank you, Christmas. Không biết anh chị mình có câu hỏi nào không? Nó tặng một đôi cổ đạo. Vậy thì nếu mà mình dùng bơm tặng gỗ ở đó là em thấy nó vừa tặng được công suất, nó vừa tặng được cái lưu lượng, vừa tặng được cổ đạo.
He meaning the tangle pump. You have two small pump, and in our thinking, these two small pump running parallel, not continuously. Correct or not?
With our tango pumps and parallel pumps, there's always the concept of redundancy.
No, but he concerns about this diagram. Actually, to them, actually, we run the parallel pump. The curve will be changing like this.
No, but every hit, the pump will double. At every hit, the capacity will double.
Not
For the one pump and the 2 or 3 or 4 pump, it can different because our piping not change. But when we run into one pump, the flow rate go up, and the head of the system also change. So the curve of the system will change when we run 1 or 2 or 3 pump.
So you're trying to say that the system resistance curve
The system curve will change when we run 1 or 2 or 3, when we add more pump.
Okay, so for now, I'll just briefly go over 3 case studies that we have done in India. And these are just go through an overview of them, how we actually offer the best solutions in terms of the different type of applications, ranging from hospitals to cinemas as well as commercial building, IT building essentially. So I will start off with the first one, which is the Amrita Hospital, right, located in Delhi. And this is where we actually helps to create the solution based for the customer using a tool called DEVA, Design Envelope Value Application. Okay, a little bit about the background of Amrita Hospital is that it's actually a research campus that consists of 5 buildings, and which is hospital, research block, convention centers, medical college, and auditorium. So these 5 blocks of buildings will be actually already commissioned this year. And originally, when this project was designed, it's supposed to consist of 1,000 tons of 10 types of chiller cool systems. So we have 6 chiller of the counterflow and 4 of the normal chillers, which consists of 3 duty and 1 standby. So in terms of the specifications of the primary and also the secondary for all the 5 blocks, we started off with the 10 blocks of chillers consisting of the variable speed primary pumps that is designed for the 4 chillers, and also the 6 remaining for the counterflow. And whereas for the other 5 blocks of buildings with the hospital, research, convention center, medical college, and also auditorium, we have the remaining 2 duty and 1 standby pumps. And of course, we also have the condenser pumps, which is also 4 with a 3 duty and 1 standby. So this is originally the design that was the drawings encompassed. So you can see here, right, this is the primary pumps that support with the water cooled, and also for the counterflow chillers. And then the condenser pump is actually attached to that. So in total, basically you have 10. So 4 plus 6. Okay. And then this is actually the drawing of the secondary, tertiary, which is the 5 building blocks that you have that's being supported. So how does Armstrong comes in? We actually have 2 different types of proposal. We actually started with this proposal for the chiller plant and as well as the tertiary pumping systems. So for the chiller pump, the primary systems, right, we actually propose the design envelope. So the is design envelope for the 200 series that we attach with our SG suction guide and FTV flow track valve. So as you learned earlier, right, we actually designed this to be in parallel series, working for the 4 and also the 6 chillers. And to do that, we actually have a controller, which is the IPC 4502, that primarily runs this. Then for the tertiary of the 5 remaining building blocks, we actually have the design envelope pumps as well, together with the PSPC attached to it. And of course, one of the things that we look at the condenser pumps as well is that there will be 2 separate sets right here. So same thing with the design envelope pumps with the SGFDV and also the controller, the IPS 4502. Do note here that the assumption flow is actually around this number, which is 3,000 gallons per minute, or around 0.68 meter cube, with a head of 25 meters. So the other proposal that we have is essentially where we split it into these kind of chiller and tertiary systems. So whereby we actually have the primary all designed with the DE pumps, as well as with the SGFDV, and coupled with the IPS controller 4502. And for the tertiary systems, we all have them attached with the PSPC, so working in parallel. And for the condenser, it's essentially the same thing with that SGFDV for the DE pumps with the IPS 4502. So what we did, whether we're offering the standard or an alternative proposal, is you can see here, this is the total base in blue, and this is the design envelope pump in red. So when I actually compare what the customer has accepted, right, with what we have offered, we actually see this is actually the savings itself. Now, what they actually did after they install, right, there's of course going to be a cost incurred with the installation cost. So with the base bid, it's actually an additional. And what we actually see in terms of the total net cost savings is actually this plus this, right? Then, after that they have installed, of course, running it, the projected annual operating cost savings, right, for the expectation from a diva is going to be over 10 million rupees. So over 10 million rupees is around 160,000 USD per year savings. So when you actually see the annual savings of this versus the net cost savings, your return is almost immediate. You want to translate that? Okay. So this is basically the first case study that we have using Diva. Now for the second one we have is actually a cinema, and this is an old cinema that has been retrofitted. So you can see on the outside it looks like one of those 60s design cinema that is now being retrofitted with the new controls and pumps. But before we talk about this, right, overall, these cinema universities all fall in this category, known as the high comfort sensitivity sectors. So just now, earlier you see the slide, right? We talk about parallel solutions, whether you're running at 50%, 75%, 100% with redundancy. For this type of buildings, it's usually slightly higher, right? Because you want to ensure that you maintain the comfort of the people living in that building, versus the 100%, which is usually more of the data centers and hospital types, right? So back to this cinema here. This is essentially what the customer is looking for. 1930s, up to the 60s type of design. So it actually comprises of two. So you have the mall area and the multiplex. So the mall area, we should basically have, of course, a primary, which is running with the constant speed, and the secondary is running with attached VFD into it at this requirement. And for the multiplex, you have the constant speed and also the pump with attached VFD as well. So one with a higher requirement, and one is a slightly lower requirement. But regardless, right, our pump tango, we can actually offer running at 50% capacity because after all, it's running parallel operation. So the drawing originally, this is what it looks like for the primary and secondary based. So you can see that the multiple vertical inline and also the with the loose attached frequency VFD as well. And then what the Armstrong proposed is basically changed it for the secondary to a tango pump. So for both the mall and the multiplex area, right, the tango pump is essentially helps to actually reduce a lot of the footprint involved, and as well as the space savings. So in terms of how this diva actually helped to show Armstrong values, is that we did the original calculation here with the base bit, and if the customer supplied the VFD separately, right, you have actually a total base. Now, Armstrong, of course, people say very expensive, and it's true. Our solution is actually higher. But we want to show that, even though we have this difference, you actually can save and recuperate back. For the first case study that you saw, the savings comes immediate. For these examples, where you can see the install cost and the net savings, so you're operating at this 235,000 rupees, but your 10-year operation is around 3 million plus. So your annual operation is around 230,000 rupee, whereas your cost savings is 277,000 rupee. So that means it's slightly less than 2 years, slightly over a year, you actually recuperate your savings back. But not only that, you can also tell your customer, after that initial payback, you're going to continue to have all these savings year after year. Compared to, if you actually accepted a much lower bid, your savings may not be able to generate that much for your entire pump life cycle. So that is the one thing that we want to show, whether you have your payback immediate or within the 1-2 year time frame. And of course, the third case that we have here is actually the IT building, Hexaware Technologies, located in Chennai. So this building here is essentially an IT building that provides a lot of consulting and resources for the development, right? So contractor. So what we did from Armstrong approach is, of course, we go to the site, we see and audit the place. And then we look at all the existing chillers, all the existing operations, the peak time and non-peak, and then we actually measure it. And then from there we realize that, how they're running the chillers using the 15 pumps, 5 chillers, how it actually ends up wasting. Because understand, you're not running it 100% capability all the time. So a lot of times you end up wasting a lot of energy for that factor when you actually power on the chiller or the pumps. So what we have the discussion with the customer is, how do we resolve that? When you actually change it to a variable primary flow and using an integrated control with our DE pumps. So what we actually helped you is actually end up reducing the number of pumps, sizing it down to actually 8. So here you actually see there's actually 2 options we propose. First one is actually, of course, customers very much aware of duty standby. So yeah, okay, we actually propose to you using our DE pumps with a duty and standby solution. Or we propose to you all the pumps running in parallel, which you have just learned. So what the plant looks like before you redesign, variable secondary, right? Here's the chiller and there's the primary and secondary pumps. Pretty much, you've seen this before in some of projects. Nothing spectacular. But what we did when we actually re-proposed our Armstrong solution with a new design, you can see the attach directly for the chillers and the pumps, right? And this is simplified as well with our IPS 4502 controls. So you can see, right, with this compared to the previous one, yeah, you can see very well, right? You have a separate panel with PLCs and VFDs, and then the differential pressures and the valves, versus here, integrated, and then you just have one attached DP sensor. So it actually helps you to save overall, if you imagine this in the plant room, additional footprint savings as well. Now, when we talk about how the two options comes in, remember option 1, option 2. Option 1 is duty standby, customers very much aware. So the base they're looking for is this figure, and this is what we propose. So customer will first say, wow, this is too much, over 2 million rupees over than what we are expected, right? Okay, no problem. But let's look at how we look at the installation cost that you're looking for. So it's around this figure and with additional costs, okay? Then in the end, what we see is actually the cost savings that you incur out of this, which is actually turns out to be with the annual cost of slightly, very small, right? So what you actually end up with, if you expect to have this kind of investment, your return back is actually over 6 years, if you run duty and standby. So obviously, yeah, we are very high and it takes a very long time for us to return on a duty standby solution. But if we go to the next one, option 2, so option 2 here, which is all the pumps running in parallel. This still remains the same, no change. But what actually changes is actually your difference in terms of the installation costs, right? And also the net savings here with the operating annual cost comparison. So when you see the comparison here, you can see your annual cost is much higher. So when you actually break this down, right, with this figure, you actually ends up saving it in less than a year. So whether you're looking at, running at the two different operations, duty standby versus running in parallel, or you're looking at, reducing the size of the pump, what matters is really the overall lifespan of your operation, because that is where the saving comes. People are always confused that, yeah, it's always high on the front side, but over a lifespan, 10 years or so, before you have a change of your pumps or control system, you will actually be able to benefit immediately. As you can see in the first case study and this second case study. So we actually proposed these two options to the customer, and customer realized this and decided to go with option 2. So what we want to show you is what exactly is this diva looks like. So basically it's nothing more than just a spreadsheet that compares numbers. So from an engineering standpoint, we show you the differences in the pumps, right, for the power rating, and then go on to the next one. Right, this is where the original saving comes in. Okay, so we pull the numbers and then do calculation. It actually shows that you can actually get savings in less than a year. Although originally you will see that it actually costs a bit more, but your annual operating cost saving itself is already more than half, right? About half. So your 10-year savings is actually quite high, because that is where the projected lifespan of this retrofit comes in. And then go to the next. So similarly, whether you're looking from a contractor standpoint or from an owner standpoint, we can actually deduct the same kind of comparison as well. So really is how we want to see that savings from a contractor who is actually doing the installation, or the owner is running this operation for 10 years. Okay, that's it. Any questions? Just a very quick one before we go into our main product.
Okay, so thank you Mr. Wesley. So topic tới sẽ là bên Armstrong sẽ giới thiệu một sản phẩm rất là mới từ Armstrong, họ gọi là Gen 5 Generation Pumps. Pump này thì sử dụng động cơ magnetic bearing, động cơ EC, công nghệ công nghệ từ trường nặng magnetic thì có hiệu suất tương đương với IE5. Thì đây là một công nghệ rất là mới của Armstrong, thì họ muốn mang tới để giới thiệu với chúng ta ngày hôm nay. Thì ông Roniki, Technical Support Leader, sẽ giới thiệu với chúng ta về cái sản phẩm này. Thì ở trên đây có một cái sản phẩm thực của dòng bơm này, thì nó tương đối là mới. Do đó nếu mà quý vị có yêu cầu lên nhìn tận mắt hoặc là để điều khiển thì có thể đến để nhìn.
Now let's look at the new models for our new generations DE pumps. Above you can see the tanker pumps with a new series. Here is our tanker pump, and this tanker pump with our closed cover. And here is a DEVIL with new generation 5, and this DEVIL and the DEVIL with a closed cover. And all of these with our new generation 5, the ratings will carry from 1 horsepower to 10 horsepower. And for the end subjects, DE we will coming soon, and this is under development and will coming soon. Okay, now let's look at the product range overview for our new upgrades. And for the ratings from 1 horsepower to 10 horsepower, this will be subsidized by our new tanker pumps. And for those about 10 horsepower, it will keep as the previous, but the pumps and also the inverters will keep as same as our generation 3, but the pump managers and also the DE technologies will keep as generation 5. Here you can see for these power ratings, we will be succeeded by our generation 5 pumps. These pumps will use our DEPM motors. DEPM means the design envelope permanent magnetic motors with the IE5 motor, IE5 efficiency. And for those about 10 horsepower, such as like DEVIL, this would be this type. And we also have the DEPC card for this. This is the newest upgrade, and also for those larger size. And for those Gen 3 pumps who want to upgrade to Gen 5, we can replace our retrofit case with the DEPC card to upgrade the Gen 3 pumps to our Gen 5 pumps. Yes, we can see for our twin pumps and for our dual arm pumps. Twin means one duty and one standby. For our dual pump means 2 duties. These ratings will be succeeded by our tankers, and for those we'll keep same as the previous. And for the tanker pumps, the two pumps, and also for the 3 and 4 pumps in parallel, the parallel sensorless control would be embedded to our Gen 5. For those about the 5 pumps in parallel, additional control panels like the IPS will be required to control the pump groups. This introduces our tanker pumps and also the dual arm pumps with a different power kilowatt ratings. For those below 10 horsepower, we can use our tankers, and those above, we can use dual arms. And for the below tanker pumps, it is permanent magnetic motors embedded like this. But for these dual arms, it is not available because the limit of the motor, the permanent, the magnetic permanent motor. Now let's look at the benefits for our new generation 5 pumps. First is a low space requirements, because 2 pumps we are in one casing. We just talk about this, and also for the second one is pipe mounted. There is no base required for the Gen 5 pumps, and also we can mitigate the risk for the pumps. Such as we can reduce the downtime, such as if one head of the pumps will be it is a failure for the one pump, so we can use a blanking plate to service for this pump. And the lowest installation cost, and we can use our DEPM, the permanent magnetic motors, with our parallel sensorless technology. And also the lowest operation cost. We have optimized our control integrations with our Gen 5 pumps, and also the best efficient stages sequences embedded to our inverters. Now this is the newest appearance for our Generation 5 pumps. We can see all of the details would be the parabolic forms. And this is reflect to our quadratic curve controls. Okay, now let's look at the new design for the clamp ring design. So for this clamp ring design, it is engineered clamps and used in many fluid applications. And this design can bear much higher temperature and also higher pressures. It can be used like in the air-operated pumps and also sanitary pumps and so on. And this also allows for the straight lines casing design and quick serviceability of closed-cap pumps. And for the hydraulic design, we have redesigned the hydraulics, and thus we can achieve the small size and also to create highest flow rate and also the smallest quiet nozzles. And also we can improve the hydraulic efficiencies to 3 to 6% points in the below 10 horsepower range. And also for the pump coverage, the power rate range based on the analytics of our currently AC online the selection tools. And also here are the 7 new pump models with broad coverage compared with our previous 12 models. Here introduce our materials of construction. For the cases, it is a little different than our Gen 3. All of these can be ductile irons, such as for the PN6 and also PN25. All of these ductile irons can be selected. And also for some specified models, we can select the 316 stainless steel. And all of the pumps would be e-coating painted. And we can see the benefit of the e-coating. It can prevent the pump seizures at startup and also reduce the service and warranty costs. And also this has the improvement for the quality of our pumps and also preserve some efficiencies over time. For the impellers, the pumps of impellers, it is available for the stainless steel and also for the bronze or iron applications with one materials. here introduce the benefits of our Gen 5 pumps, rating from 1 horsepower to 10 horsepower. And we can see the lowest operation cost with our parallel sensorless technology to control the sequence the pumps, and also increase the efficiencies. Increase the efficiencies with the 3 to 6% points, and also the 6 to 12% points. This compared to the induction motors, and also plus our plus the separate inverters installation, and also with our pump managers to perform the management, the efficient management, and also we have the lowest install cost with our parallel operations of the tangles, and also with approximate the redundancy level, and actually it has some additional functions like the auto balancing, the minimum flow, and also the maximum flow functions can be selected. And the last one, it is easier to commission and service. Like we just talked, it is based on the cloud, so all of the data can be trained and also recorded at the cloud. And in the job site, we can use the telephone, the handphone or the laptop to commission these pumps. This is just we showed the different types of the solutions. The left hand shows the end sections with the separate inverters and also the sensors. This requires the base mounted. So for the middle picture shows our DEVIL with in parallel. So it has some benefit for this to reduce the installed powers and also integrated controls with our PSPC and also the sensorless technology and high levels of redundancy. And for the right hand of the Gen 5, the tangle pump solutions, it has some more benefits compared to our DEVIL solutions. It reduced the installed powers and also the super efficient IE5 efficiencies for the motor, and also for the sensorless technologies embedded, and also the PSPC embedded, and high performance, high level of redundancy, and also the lowest space requirements for the tangles. Okay, here shows the duty standby desire and compared to our 50% redundancy in parallel desire. Left shows the larger the motor and the selection would be larger, but the right hand shows it can be selected as smaller. Yeah. Here is the comparison of this the VIL solution compared to the tangle. So we can see that for the weight and for the installation weight and also installation footprint and also the cost, this is would be much improvement for this. And also this shows the tangle pumps compared to the our twins. Twins means the one duty and the one standby. But this shows our tangle pump compared to the twins. We have also the much improvement for these different sections. Okay, now let's look at the newest DEPM motors. We means the design envelope permanent magnetic motors. So this motor has the 6.3-inch the touch screen and a colorful touch screen. And for the efficiency, it can meet the European IE5 European standards. And this would be have about the 36% higher than the IE3. And compared to the traditional induction motors and also the drivers, the separated inverters installations, it would be the efficiency improvement for the about 6 to 20%. And also we have the possibility to reduce the weight and also the physical sizes. Yeah, this is a comparison for the 4 kilowatts, the induction motors plus the IVS inverter compared to the DEPM motors. You can see this is 68 kilogram, but for DEPM it only the 18 kilograms. Okay, here shows the interface of the DEPC card. Like this shows we can see the trend graphs and also some parameters, the flow, head, speed, and power, voltage, current, and so on. And all of these units can be set up. And for this activation service, we can activate some functions like the energy performance border and protection borders. Like this protection border, it includes such as the minimum flow protection, the maximum flow protection, and also have the zone optimization border, dual season setup, and so on. For the dual season setup, it has benefit for the pumps that will be used in winter and also in summer. It has a 2 seasons setup. And also pump managers available. Here shows the curve, the trend for the flow, and also have some the pump configurations. We can configure the pumps through the pump control and also activate the service. So we can see this touch screen. We can configure all the parameters through this touch screen, and also we can configure and set up the parameters via your cell phone or your desktop on the job site. If connected to the internet, also can be done remotely. This. Yeah, later we will demonstrate these functions. Okay, here is the active performance management. We mean the pump managers, and also we will do the demonstrations for this. Firstly, I would like to introduce the benefit for this pump manager. First one is this is cloud-based for these pump managers. All of the data will be stored at the cloud, and all of this data would be analytics by specified industry and pump specified insights. And also it has higher reliabilities and also sustained optimal performance. Okay, here we will do the demonstration for these pump managers first. Can I use? Yeah, okay. So now let's log in the pump managers. So all of the pump motors can be found all over the world. So we can find specific motors you want, whatever.
So basically what we're showing you is actually our master login. By master login, this means is our administrator login can see all the pumps that are connected globally. So you'll see the location in Buffalo, Dubai, Frankfurt, Germany, Manchester, UK, etc., etc. But of course, when you create the login, you will only see your specific site installation, right? So if let's say it will be in Ho Chi Minh City, next one will be in Hanoi or Da Nang, etc., etc., right?
Yeah, such as we chose the one from in Shanghai plant. Then you can see this is the status transmitting the data, and then we get the file data, the last remember.
So this is actually live data, real-time information, right? So that's why it says transmitting it. We actually connected to the pump directly in Shanghai to get this performance curve.
Yeah, here has some text, the performance map, the real-time vibration, flow profile, load profile, and energy savings we can see here, real-time. Yeah, this is the real-time for the flow, and also head powers you can choose. Yeah, we can try. Yeah, this is head and also the power. And moreover, for this Gen 5 pump, we have embedded the vibration sensors. So we have the three axes, the XYZ axis, the record for these vibration values. And here shows the flow profile, load profile, and the energy savings. Here is the pump information. This is fault management. So now let's look at the left side. This is the menus for the different functions. It is the location, trend, settings, admin, and report. And also we can view or adapt and salesforce. This is two links to another tools. We can see the locations. So all of the pumps would be displayed in the map. Those this is flags, means has some warnings or alarmings. For those the gray, this is gray flashing, means it is offline for this pump unit. So for this one, this is normal running. Now let's look at the trend. Yeah, it's just what we talked about. And the settings. So we can set the pumps, some contact information, blah, 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 and also some generals. Yeah, general. And now let's look. This is admin. Admin, you can choose the. Pick one. You can set up the users, the companies, and also another function is for the download. You can pick one pump what you want and then download the report and the data what you needed. This is firmware, the version, the user guide, and submitters and I/O manuals. This is user approval. Now let's look at this report, such as we just picked here, right? Then you can the report is available for download. You can download the month by month, such as for the June. You can click here. So the report looks like this. It has the summaries of the pump, such as for the hourly flow profile, the monthly flow profile, and so on. And this shows the energy savings. Yeah. Here is the report shows. And besides the individual pumps, the report, we have the raw data. It is also available on the pump manager. You can see all of the parameters, the head, the flow, power, and so on. So this is the demonstration for our pump managers. So then I would like to introduce the demonstrate for the gen file access. Can we need to connect here. So for this demonstration of the Gen 5, the access, I would like to introduce first in the computer. Then you can go here to operate the touch screen. Yeah.
Okay, so we would like to invite a few people up to actually take a look at the interface, because what you see here is the browser mode, whereas the interface directly on the panel is, because it's smaller, so it looks slightly different. So we already seen here that it's connected already, so we can directly go into the pump itself. So this is the pump ID, that your IP address.
Then after you log in, you can see the dashboard for the different parameters. It is a head, flow, speed, blah, 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 blah. Yeah. All of the data can be shown at the dashboard. And the left side, it has the data, the settings. You can click here. Data. Yeah. It has the actual and also the change. And click the settings, the below pumps. Yeah, you can set up the pump parameters through the settings, such as the pump tag, and also such as the limit for the low speed and also the high speed. And below, yeah. And also the communication parameters can be set up via this browser, such as for the Modbus ID, the baud rate, and also the BMS, the protocols can be selected as standard, such as for the Modbus, it is the serial or the TCP/IP, and also backnet is available for the serial and also the TCP/IP. And below shows it has two connections. It has the Wi-Fi setup and also the Ethernet setup. So if you would like to use the Wi-Fi setup, such like this pump shows, we have different modes, such as the disable, Armstrong Connect, station, and access point. So now for the current mode, it is the access point. So for this mode, access point, it can be acted as the routers. So we can use our cell phone, our desktop to connect to the pumps. So if you use the station mode, it only acts as the substations. Yeah, and also for this Ethernet setup, you can set up the IP address, the host name, and so on. Okay. Yeah, general. This general setup, you can set up some like the time-based recording, such as it is defaultly by the 600 seconds, and also the time, date, and also the units, the default units. Here is a setup for the alarm setup, such as for the alarm, the warnings, and also like such as for the low backup battery voltage and the low system temperatures. You can set the values what you want. And also the administrative. Yeah.
Đúng. Thực ra các cái setup này trên cái portal này mình có thể setup thẳng trực tiếp trên cái màn hình touchscreen của cái bơm. Nếu anh chị mình có thể lên đây mình thử nhấn thử để setup thử, hoặc là mở điện thoại ra connect thử để mình sẽ ra đúng cái portal như vậy luôn. Tại vì cái bơm mà đang ở chế độ mở nên mình không có để password, anh em có thể mở internet lên và vô DE 001 để thử, mình sẽ vô reset y chang như vậy. Thì đó là một cái công năng rất là mới của cái bơm này, mình thể kiểm soát bơm từ xa, setup control bơm từ xa, như kiểm soát hệ thống bơm từ xa. Thì nó sẽ lợi ích hơn là việc mình phải đi check từ xa. Thì nó sẽ lợi ích hơn là ở đây là mình có thể dùng cả wifi lẫn internet. Thì cái đó mình phải xếp riêng cho một cái hệ thống của mình. Nó là một cái lợi thế tương đối mới hiện nay và cái xu hướng mới hiện nay của tất cả các sản phẩm. Đó. Thì anh chị có thể lên đến đây để touchscreen thử về để độ nhạy cho các sản phẩm của mình, nó sẽ như thế nào.
So now we want to do a demo. So anyone want to volunteer, use your handphone and connect to the pump. Okay.
Đó là
So step by step.
First step, you need to log into this system. Yeah. Now this is log out, then log in. And then you need to set up the you mean the unit. Unit can be set up here. The unit, for example, flow, pressure. Let's switch.
So we can
Yeah, it's okay.
and the flow will be indicated when the balloon, or we can set up
Here is
the design for operation.
you mean the duty point, right?
Yes, yeah.
The pump information. If you want to connect your cell phone to these pumps, the first step you need to set up is for the Wi-Fi connection, because this is ready for access. You need to put the mode to the access point. Then we talk about for these sessions. The first one, it is the energy savings. It will achieve the 65% savings compared to the induction motors with IE3 and also the separate VFD installations. And second one, we introduced our sensorless tanker pump with sensorless technology embedded. And the third one, we introduced the redundancy concept, so we can say goodbye for the duty standby the concept we can say hello to the redundancy concept for the new design. And the fourth one is the pump managers we just showed to you, all of you. We can improve the almost 40% the energy savings. Last one we showed will be a new excellent coverage for the low flow areas and high energy efficiency design, and improve for the 11 to 55 kilowatts coverage. Here shows some the exposure drawing for the motors. Here is the permanent magnetic motors we can see. Here is the rotors with a permanent magnet, and this can generate the magnetic flux and eliminate the windage. And for our DEPM efficiency comparisons, we can see here is the RE3 efficiency induction motors plus the IVS inverter, and here is the power rating. Here is the Armstrong DEPM motors. At full speed, we can see the improvement is higher. But at the part load, such as the 50% the speed, it will achieve much higher efficiencies improvements. So this shows that at the part load, it will be more benefit for the DEPM offerings. And here shows the induction motors compared to the permanent magnetic motors. We can see here for the induction motor, it has a 2 power, 6 power, 4 power, and so on. But for the DEPM motors, no, it is no traditional powers for such motors, and it lacks the car engine. Yeah, it only has the operation speed, what you needed to operate. And for the operating frequency, it has 50 hertz, 60 hertz. But for the DEPC car, it can run at 240 hertz, and also even 400 hertz. So with this higher speed, we can reduce the Collier torque. This is significant for the DEPM, the permanent magnetic motors. And also for the frame size, it can be selected as smaller one or two frame size for the frames.
Okay.
Thank you all.